Welcome to Maestro Math Vortex Spy as we stroll through the beautiful Buffalo Wallow Park in Odessa, Texas, surrounded by the stunning scenery and the mesmerizing duck migration. We'll dive into a fascinating math adventure. Today, we're exploring the multiplication and division of positive and negative decimals. Just like the ducks navigating their flight paths, we'll break down these concepts step by step to make them easy to understand. Let's soar into math. Now, let us go to our first scenario about the duck migration impact. Now, in this scenario, it says here that each winter, a group of migrating ducks arrives at Buffalo Wallow Park. However, due to environmental changes, the number of ducks has been decreasing by negative 2.5% per month over the past 4.8 months. So let me repeat that. It's actually decreasing. Let's underline that. It's actually decreasing by negative 2.5%, negative 2.5% per month over the past 4.8 months. Now, the question is, what is the total percentage change in the duck population? Okay, so this is an interesting scenario, and I do believe that we already have taken up in our grade six level. I'm not particularly sure, or grade five, how we can actually multiply and divide decimals, right? But in this scenario, it gives us a hint that we will actually be multiplying. Okay, excuse me. So the operation that will involve in solving this problem is actually multiplication. So let us write there, we are actually going to multiply. Okay, we're going to write here, we will multiply. Okay, and then so what are we going to multiply? Okay, that's a good question to ask ourselves. What are we going to multiply? So about this problem regarding of course the duck migration impact. All right. So now we will now have to write our solution. Okay. Okay. Let's underline that. So what are we going to multiply in this situation? Okay. All right. Okay. So we're going to multiply negative negative 2.5. Okay, let's fix that writing. So we're going to multiply negative 2.5 by 4.8. All right. Let me repeat that again because sometimes I would mistakenly say things, and I want to repeat it so that it would be clear to all of you, my viewers, that I said the right thing. Okay, so we will multiply negative 2.5 times 4.8. Now, how do we multiply decimals like this? Of course, there is actually uh, procedure for us to do that. How will we multiply? The first thing that we need to remember is to ignore the decimal points. Okay, we have to ignore the decimal points and multiply as whole numbers. So in this case, I will not. We will just ignore, of course, the decimal points between negative 2.5 and 4.8. Okay, and we'll just multiply them. So we have 25 and 48. Okay, we'll multiply them. So what is 5 times 8? It's 40. Okay, carry 4. So um what do you call this? What is 8 times 2? 8 times 2 is 16 plus 4. That would give us what? That would give us of course 20. Okay? Yes. 8 times 2, 16 plus 4 is 20. Yes, correct. 100% accurate. All right, and then 4 times 5. 4 times 5 is actually 20. Carry 2. And then 4 times 2 is 8 plus 2. Okay, plus 4 times 2 is 8, plus 2 is 10. Okay, there you go. And then we're going to add them. Okay, so bring down 0, 0, 2, 1. Okay, now what do we do next? The next thing that we're going to do is to count the decimal places. So when I say count the decimal places, count the total number of digits to the right, okay, of the decimal point. Let me finish that statement. Count the total number of digits to the right of the decimal point in both numbers you were or you are multiplying. All right. So we just multiplied. I will of course disregard the sign first. Of course, we'll go back to that. Okay, later. So we have 2.5. Okay, 2.5. Yes, did I say it right? Yes, 2.5 and 4.8. All right. So if we are going to count the decimal places to the right of the decimal point of both numbers we are multiplying, how many is that? Okay, so to the right, right? So here we have one decimal place, one decimal decimal place here, right? To the right, correct? Okay, one decimal place. Because we're just following that statement. Count the total number of digits to the right of the decimal point in both numbers you're multiplying. So here, 2.5, we have one decimal place. Okay? And I actually put a curve there for us to see. And then for 4.8, so let me repeat that again. So for 2.5, we have one decimal place. For um what do you call this? 4.8, we also have one decimal place. Yes. Okay. So all in all, we have what? We have the total is two decimal places, right? Okay. So what do we do next? What do we do now? The next step is to place the decimal point in our product. Of course, our product is 12, but we have to put the decimal point in that. Okay, so we will count from right. So starting here, right right to left, yes, in the product, the same number of places as the total number of decimal places we just counted in step two. Yes, and place the decimal point. So we have two decimal places, right? Two decimal places. Two decimal. Sorry about my writing. We only have a very, very, limited space in my slide. So we have one decimal place plus one decimal place. So we have all in all a total of two decimal places. So we're going to start from the right of our product. So that will be 1, 2, because as we said, we have two decimal places. So therefore, it would be what? The answer would be, okay, what would be our answer? The answer would be 12. Okay? Okay. So it's actually 12. But hold up. Okay. So since math is very, we're very important, we're very particular, not important. We're very particular with the rules. We go back now to our signs. Okay. Now, remember when we discuss about integers, particularly in what was that? We discuss about multiplying integers when we say negative times positive. Of course, the result would be negative. Okay, right? Let me repeat that because I wanted it to be correct and perfect. All right. So when we multiply signs, particularly negative, to a positive, negative times positive would give us negative. All right. So here the answer would be negative 12. Negative 12%. Why is it negative 12%? Because it's asking us what is the total percentage change in the duck population. Okay, now we can now make our conclusion. Okay, let's erase this one. Okay, so when we multiply negative, when we multiply, okay, let us put a circle on that. When we multiply negative 2.5 to 4.8, our answer would be, of course, negative 12%. All right. Now let us now. So that's when you multiply negative 2.5 to 4.8. So you'll have negative 12. Okay. And going back to the rule of sign, negative times positive is negative. All right. Now we can now make our conclusion over here and let's erase this one. All right. So we can now say about the duck migration impact. Okay. We can now say what? We can now say that the duck population, okay, let us write it. Okay, let's say here, so um, the duck population, the duck population, okay, the duck population, sorry about my writing, population, yes. The duck population decreased, that's why it's negative, right? Decreased, yes, by 12%. Okay, so I would repeat that. So the duck population decreased by 12% over 4.8 months. All right. So that's it. We were able to answer this scenario, particularly on duck migration impact. Oh, by the way, that photo was actually taken from the Buffalo Wallow Park. Okay. So I repeat, we were able to solve this scenario involving the duck migration impact. And that photo, as I was saying a while ago, is actually taken while I was making a stroll, of course, in the Buffalo Wallow Park. Yes. All right. So yes, yes. Okay. So that problem wasn't that so difficult, right? It wasn't so difficult because we were able to answer it easily, right? Okay. Now, just to give you a short information about the Buffalo Wallow Park, it's actually located in 4100E. Yes, just to give you a short information about it. If you happen to visit, of course, Odessa, Texas, I'd like you to have a short trivia information about it. Okay, particularly on Buffalo Wallow Park. So it's located at 4100E in 42nd Street in Odessa, Texas. It's very tranquil outdoor space. That's true. It's actually man-made, featuring man-made lake, popular for fishing, yes, and picnicking. So if you want to fish there or to have picnic with your family, you can actually go there. Yes, it's free, right? Visitors can enjoy a paved walking loop around the lake, observe various sculptures, and feed the ducks. So when you go there, don't forget to feed the ducks and the pigeons and waterfall. Yes, waterfowl, I mean to say. The park also includes a dog park for a pet enthusiast. Okay, so if you want to walk your dog around the park, you can just go there. Particularly for those who are really enthusiast with pets and dogs and cats. Maybe you can take them there too. Okay, all right. Now, our lesson for today is about multiplication and division of decimals. So, we're actually focused on multiplying and dividing positive and negative decimals. Let me repeat that. Our lesson is about multiplication and division of positive and negative decimals. All right, but before we go there, let us try to go over some vocabulary, because it's very important for us to really know what those words mean, for us to be able to apply those words whenever we're solving or whenever we want to what do you call this? We want to understand it better. And my professor in math, I may just quote her, would always say that we must always know what mathematical definitions are. Okay, so we have decimal. Of course, the decimal that includes a decimal point. Yes, yes, of course. I think if I'm not mistaken, with all humility, I have discussed this in our previous video lesson on addition, I think, and subtraction of positive and negative. Is that right? Addition and subtraction of positive and negative decimals. Yes. So it's actually representing a fraction of a whole number. All right. Now we have positive decimal. So when we say positive decimal, these are decimals that are actually greater than zero. So our examples are zero point 0.5. Yes, they are greater than zero. We have 2.75. Yes, 2.75. And then we have negative decimal. So negative decimal um, means that they are decimal number that is actually less than zero. So if we say that positive decimal are decimal number greater than zero, now the negative decimal are decimals or decimal number that are less than zero. Okay, decimal number less than zero. Okay, so what are our example, or what is our example? Okay, so less than zero, yes. So our examples are negative zero point 0.6. That's negative 0.6. Then we also have negative 3.14. Yes, negative 3.14. And then we have multiplication. So when we say multiplication, of course we know that it's a mathematical operation, one of the four, right? Addition, subtraction, then multiplication and division. So it's a mathematical operation where one number is actually added repeatedly. Yes, it's added repeatedly by another. Now, in decimal point, you multiply, or we multiply numbers as if they are whole numbers. That's what we did a while ago in the scenario number one about the duck migration impact, right? We actually treat them first as whole numbers. Yes, whole numbers. And then we count the total number of decimal places in the factors. Okay. So when you say factors, these are the two numbers you're multiplying. Yes, factors are the two numbers that you multiply to each other. And then, of course, the result would be called as product. That's in multiplication. Okay, so then count the total number of decimal places in the factors, okay, to place the decimal point in the product. Okay, and then we have division. Okay, of course, when we say division, we are actually splitting a number into equal parts. That is correct. That is correct. Now, when we are dividing decimals, you may actually need to adjust the decimal point to make the divisor a whole number. So actually, your goal is to make them your goal is to make your dividend and your divisor as a whole number. So it's easier for us to actually make our long division easier. Okay, so let me repeat that. The goal is to both change the dividend and the divisor into a whole number, so it's easier for us to actually do the long division. It's actually long division, so it's easier for us to do that when both dividend and divisor are actually in the whole number form. All right, so we must not also forget about the sign rule. Okay, the sign rule. So for multiplication and division, so when we say multiplication, what would be the sign rule? So it's actually positive times positive is positive. Okay, and then we have negative times negative is positive. So let us repeat that so we can remember. Positive times positive is positive. Positive times positive is positive. Next, negative times negative is positive. Okay. Negative times negative is positive. So that's only in math, right? When only two negatives, when you multiply two negatives, it would actually result to a positive. Wow, that's only in math. Okay, and then the next one would be positive times negative, correct? A positive times negative is negative. Okay, just like our example a while ago. Negative. Oh no, it's the last one. I mean to say. Okay, so let me repeat that. Positive times negative. Positive times negative is negative. All right, and then the last one is negative times positive is negative. Okay, so a good example is what we just had in our scenario. We have negative 2. Okay, what was that? Let me remember. Okay, so that was negative 2.5, negative 2.5. Okay, let me use my pen. Hold on. Yeah, there you go. So we have negative, this is a one example. All right. So negative 2.5 times 4.8. So that's an example. Negative times positive is negative. So that's why our answer would be negative 12, right? Okay, negative 12. Yes. All right. Now for division, we'll have positive divided by positive is positive. Again, positive divided by positive is positive. Okay, it's pretty much close than pretty close to multiplication, right? But the only difference is the operation, of course. Now next is positive, okay, divided by positive divided by negative is negative. Yes, and then next is negative divided by positive is negative. All right, and then of course negative Okay, hold on. Negative divided by negative is positive. All right. So again, negative divided by negative is positive. So we should not forget that because these are very important. The signs are very important, especially our topic is about multiplication and division of positive and negative decimal. Okay, so we must be aware of these sign rules. Okay, all right, there you go. Let's move on to the next one. Okay, now the next vocabulary would be about absolute value. So when we say absolute value, again, I have touched this. We actually have touched this in our lesson about addition and subtraction of positive and negative decimal. So it means the distance of a number from zero. Yes, in the number line. Yes, we encountered this in our previous episode. Okay, on the number line, ignoring its signs. Excuse me. Now, in decimal operations, it helps us what? To simplify multiplication and division of negative numbers. So, again, it helps simplify multiplication and division of negative numbers. And then I have already talked about the product. Yes. So that's the result of multiplication. For example, I'm not going to expound this further because we will be able to expound that further in our examples as we go further. Okay, so we'll just give an example. So the product of 0.4 times 2 is 0.8. Yes, that's correct. Okay, so zero point 0.8 is actually your product. Now, how about for your quotient? Okay, quotient is the result of your division. So you have your dividend, right? Dividend divided by your divisor. Yes, I believe that's right. Okay, so the answer, but we will touch that, okay, later on as we go along. Okay, so for example, the quotient of 4.8 4.8 divided by 2, okay, will give us 2.4. So 2.4 is actually uh, 2.4 is actually your quotient. All right. And then rounding. Okay, so we will encounter this in our examples. So rounding means the process of adjusting a decimal number. Okay, to what? To a specified number of decimal places. Okay, so it's adjusting a decimal number to a specified number of decimal places. Okay, it's often done after you multiply and uh, after you have after you have done division and multiplication. And then decimal places, we already encountered this in our introduction. Okay, so this means the digits to the right. Okay, the digits to the right of your decimal point, indicating the precision of a decimal number. All right. Okay, next, the long division. We will also perform this long division of our decimals. Long division of our decimals is a method used for dividing decimals, okay? Where you adjust the dividend and divisor to remove, of course, the decimal point by multiplying both by 10, 100, or uh, another power of 10. Okay, so we will encounter this. I already mentioned this a while ago. Okay, I already have given us a bird's eye view. Yes. All right. So we move on. Now, here's what I'm talking about. We will now be, we will now be, excuse me, we will now be having our examples. But first, of course, we need to have our example first when it comes to multiplying positive, okay, multiplying. Oh, what happened to my pen? It's moving by its own, on its own, I mean to say. So we will have, of course, multiplying positive and negative decimals. Okay, so let's begin with the first one. Of course, I have already mentioned how we multiply, right? Okay. Yes, I have already mentioned that to you already. Yes. Okay. So in our scenario number one, now first things first. Now this is easy. This would be easy. Letter A. Again, let me. Sometimes my hands is shaking. All right. So let us remove that again. Okay. So this would be easy for us. Okay. So we will multiply 4.5 times times 7.3. Of course, the rule is ignore the decimal points and multiply both of these as whole numbers. And it's easy for us. When it comes to sign, if we go back, okay, so we're dealing with positive times positive. So therefore, positive times positive, the result, positive times positive is positive. Okay, so all we have to do is just multiply this. Okay, so 4.5 times, yes, 4.5 times 7.3. First step, ignore times 7.3, yes. Ignore the decimal points and multiply as a whole number. Okay, so this will be 45. We have just ignored the decimal point, and 73. Now we multiply. So what is 3 times 5? 3 times 5 would give us what? 3 times 5 would give us 15. Okay, that will be 1. Okay, carry 1. 3 times 4, 12 plus 1 is, okay, okay. What is 3 times? We're going too fast. Okay, sometimes, as I told you, sometimes I say things that is not supposed to be. Okay, so 5 times 3. That's why I keep it. I keep to say those words so that because we are really in math, we really need perfection here. Okay, so 5 times 3, we have 15. Carry 1. Yes, that's correct. 3 times 4 is 12. Plus 1 is actually 13. Okay. And then 7 times 5, that would be 35. Carry 3. Okay. 7 times sorry, 7 times 4 would be 28 plus 3, 29, 30, 31. Okay. All right. And then we add. See? Simple, right? Simple dimple. Bring down 5. Okay. So what is 3 plus 5? That's 8. And this would be 2. Why 2? 1 plus 1, 2. And then bring down 3. Now, we now have our product. Now, the next step is for us to count the what? We need to count the decimal places. Of what? Of the digits to the right of the decimal point. So, the decimal point in both numbers, you are multiplying. So let's have it here. So 4.5 and 7.3. Now let's count the decimal places. So 4.5 has one. 4.5 has one decimal place, one decimal place. In fact, 4.5, yes, has one decimal place. 7.3 has also one 7.3. Yes, 7.3. Has one decimal place too. So the total would be two decimal places. Okay, two decimal places. Yes. All right. Now, the next thing is, okay, so since we were able to see how many decimal places do we have for both 4.5 and 7.3, which is a total of two decimal places, we will now count from right to left of our product. Okay, the same number of places as the total number of decimal places you counted in our step two, of course. So we will count from right to left. Okay, since we have two decimal places, we'll start at the right. Of course, I'm referring to our product. So one, we started to the right, going to the left. Two. Why two? Because we have two decimal places, right? Yes. So our decimal point now will be here. So our answer now will be 32.85. Okay. That is our answer. Let me repeat that. Our answer, final answer, would be 32.85. Yes. And why is it positive? Because both 4.5 and 7.3 are both positive times positive. So therefore, the answer is positive times positive. The answer is also positive. Okay? Which is 32.85. Yes. All right. See? So, we don't really multiplying decimals is not that too difficult at all, right? So it's actually easy so long as we actually know the rules. Because if we don't know the rules, the problem is we uh, we will really be confused. So that's why we have this video lesson in order for us to really be able to understand mathematical concepts, and particularly on multiplying positive and negative decimals. All right. Okay. Let's go to the next one. Okay. So we already answered. Um, let's just check it. So we're done with A. Okay. We're now going to B. Okay. B is also easy. Okay. So of course, let me deal first with the signs. So it says here negative times negative, because I can see that their signs are both negative. Yes, I can see that both of their signs are negative. So, and the operation involved is um, multiplication. So, what does it tell us in the sign rule? Negative times negative, negative times negative is actually positive. So, negative times negative is positive. Okay, so we were able to deal with the sign before we started multiplying, but that's okay, right? Okay, let us now multiply. Okay, again, the first rule is to ignore the decimal point. Okay, all right, yes, ignore the decimal points and multiply as whole numbers. Okay, so we have here, excuse me, we have here uh, 2035. Okay, I'm gonna multiply that to, I remove already the decimal point. Not removed, but ignored. All right. Let us try to give more space here. Let's erase that. Okay. So we have, okay, 2035. All right. 2035 times 5,411. Okay, let's multiply now. All right. Now, first things first, we have to be very careful too. Okay, so in multiplying, take it slow, right? So what is five? What is 1 times 5? That is 5. Okay, 1 times 5, 5. Okay, 1 times 3, 3. Okay, 1 times 0, 0. Yes, that's correct. Hold on. Okay, so that is 1 times 0 is 0. Okay, yes, 1 times 0 is 0. Okay, 1 times 2 is 2. All right, next. Okay, next is 1 times 5, the same. 1 times 5 is 5. This would be 3. This would be 0. That would be 2. All right, next. All right, 4 times 5. 4 times 5 is 0 because it's 20. All right, carry 2. Hold on. My pen is not, yeah, that's 2. Okay, and then 4 times 3. 4 times 3 is actually 12 plus 2. So what is 4 times 3 is 12. 12 plus 2 is 14. Yes, that's 14. All right. Carry, we put carry 1 here. All right. So times 4 times 0, excuse me, 4 times 0 is 4 times 0 is 0 plus 1. Okay, will give us 1 here. Yes, 1. All right. And then 4 times 2, 4 times 4 times 2 would give us 8. Yes, over here. Yes. Next. All right. Next is 5 times 5. 5 times 5 would give us what? 5 times 5 would give us 25. Yes. Carry 2 again. Yes. 5 times 5 is 25. Yes. Carry 2. Okay, then 5 times 3 will give us 15. Yes, plus 2. 15 plus 2 will give us 17. Okay, 17. 5 times 3, 15 plus 2, 17. Carry 1. 5 times 0 is 5 times 0 is 0. Okay, yes, plus 1. Yes, plus 1. We'll have 1. All right. Okay, and then 5 times 5 times 2 is 10. There you go. Wow, that was a long one. Then we add. Okay, let us add now. Bring down 5. All right, so 3 plus 5 is 8. All right, then this would be, 0 plus 3 plus 0. 0 plus 3 plus 0 is 3. All right, and then this would be, so yes, 4 plus 5, 9, 10, 11. Okay, carry 1. Okay, yes. All right, next is 7, 8, 9, 10, 11. Okay, carry 1. And that will be, yes, that will be, yes. All right, where were we? I was just kidding. Okay, so 8 plus 2 is 10. Yeah, because 1 plus 8 plus 1. 1 plus 8 plus 1. Okay, so that will be 10. Carry 1, that will be 11. See that? All right. So, yeah, that was a tough one. So that's now our answer, okay? Yes. All right. Now, the next thing that we need to do is, of course, we need now to count the decimal places. Count the decimal places of the digits to the right of the decimal point in both numbers you or we were multiplying. All right. So let us now count the decimal places, of course. So we can see here that Okay. So how many were those decimal places? So I will disregard the sign again. So we have tw- uh, 20 point 20.35. So here we have two decimal places. Two decimal place. Yes. Two, hold on, two decimal place. Yes. Because one, two. Yes. That is actually after, yeah. That is the total number of digits to the right of the decimal point. To the right. Yes, to the right of your decimal point. So we have two decimal place for 20.35. Okay. How about for, yeah, that's for 20.35. How about for 54.11? It's the same. One, two. Okay, we have decimal, two decimal place. All right, so we have two decimal place for 54.11. Yes, okay. So the total would be four decimal place. Okay, and then the next step is for us to the next thing is for us to count from right, because we're now placing the decimal point in our product. So count from right to left in the product, the same number of places as the total of decimal places you counted, or we counted. We just counted it here. Okay. So since we have four, we're going to start with right to left. Okay. Four decimal place. So one, two, three, four. All right. Yes. Yes. Okay. So therefore, the decimal point would be here. So that will be, yes, that will be 1101 point, or 1101 point, uh, 0.1385. 0.1385. Yes. Now you can still actually round this one to two decimal places. Yes. You see, that's why we have that in our vocabulary a while ago. Let's round it to two decimal place. Okay. So how will we do that? If we noticed the third digit after, which is 8, the third digit after the decimal is actually, the decimal point is actually 8. Now, since 8 is greater than or equal to 5, oh, sorry. Um, yes, hold on. Since 8, okay, we have here, of course, since 8 is greater than or equal to, yes, that's correct. I'm sorry. I said it correctly. Since 8 is actually greater than or equal to 5, we round the second decimal, which is 3. So we will actually place up by 1. So we're going to add 1 here in our uh, second digit here, which is 3. So this becomes 1101, 1101.14. Okay? Because why is it like that? We rounded it to two decimal places. Okay? So our final answer would be 1101.14. Okay? And we go back to the sign because we might forget that. Okay? Okay, we're talking about multiplication. Okay? So negative times negative is positive. Okay? So that's why our answer is positive 1101.101.14. Okay? All right. Yes, because that is what the rule is telling us. Negative times negative equals positive. All right. There you go. You see, it's just easy, to multiply positive and negative decimals. Okay. Right. All right. So we move on. I hope we're really getting it and it makes sense to us. Okay. All right. Now, this time we will now go to division. Okay. Of what? Division of positive and negative decimals. Okay. So we're done with multiplication. That's finished. All right. So we will now go to division. Okay. So how do we divide? Of course, when we divide, just to give you an overview, when we divide, to divide decimal, okay, uh, to divide a decimal by another decimal, first we need to convert the divisor. What is the divisor? The divisor is actually the number you're dividing. Okay? Yes, the number you're dividing by. Okay? I almost forgot the word by. The number you're dividing by to a whole number. Okay? By moving the decimal point to the right. Okay, let's remember that. Then move the decimal point in the dividend. Okay, what is the dividend? The dividend is the number being divided. So let me repeat that. The divisor is the number you're dividing by, and then the dividend is actually the number being divided. Yes, the same number of places to the right. And then we will actually perform long division as usual. All right, so let's start. But before that, let's deal, of course, with our sign. So, it won't bother us in the end, of course. So, here for the first one, we have here, okay, we're talking about dividing, right? So, we have the sign is, the sign of the dividend is yes, it's the dividend. Okay, so the sign of the dividend is negative divided by. We're not talking about multiplication already. We're talking about division. Okay, so negative, excuse me, negative divided by positive. So of course we can directly say that the answer is negative. Okay, so negative divided by positive is negative. Can we look at our sign rule? What was that? Okay. Negative divided by positive. Negative. Here it is. Negative divided by positive. Yes, it's negative. Negative divided by positive is negative. That's division. Division. Okay. All right. So what we're going to do now is, how about for the letter D? For letter D, it's negative negative divided by negative division. Okay, negative divided by negative. What's the answer? Negative divided by negative is positive. That's division. Okay, it's positive. Okay, all right, so we move on. Okay, all right, let's try to erase this one now. Let's remember the signs. Okay, so negative divided by positive. Negative divided by positive is negative. Yes. All right. Next is negative divided by negative is positive. Okay. Again, one more time. Negative divided by positive. Negative divided by positive is negative. Okay. And then lastly, negative divided by negative. Negative divided by negative is positive. All right. Good. Okay. I will we'll now go to the division process. Okay. All right. So again, negative divided by positive, negative divided by positive is negative. And then negative divided by negative is positive. Okay? All right. Because sometimes I would say things that is not correct, but for me in our video we really want it to be sure that we're saying the right stuff. So negative divided by positive is negative. Negative divided by negative is positive. All right. Many times we already mentioned it. All right, so let's do the a long division. Okay. All right, let's erase that one. Okay, so for this one, what we're going to do here is, of course, um, we have, of course, I'm going to disregard the sign first. So our divisor for letter C is 1.5. It's 1.5, yes. And our dividend is 2.45. All right. So we're going to what I just mentioned a while ago. We're going to convert the divisor to a whole number because that's the goal by moving the decimal point to the right. Okay. That's content. Okay. The decimal point to the right. We will move the decimal point to the right. Okay. All right. So let's move it to the right. So it's now 15. Okay. So you see it's now a whole number. Okay. So that will be 15 here. So if you have moved your decimal point in your divisor, you must also move the decimal point in your dividend. The same number of places to the right too. Okay. The same number of places to the right. All right. So one. Okay. Okay. So that would now become 24.5. Now, the goal is for both the divisor and dividend to become a whole number. That's the goal, to make them both a whole number. All right, so I will still need to move the decimal point in my dividend, okay? So to the right again, 1. Okay, so that would be 245. Yes. So if I move the decimal point in my dividend, I have to move the decimal point in my divisor too as well. So that would be 150. You see, both of them now are whole numbers, 150 and 245. Now, we will now perform long division. Okay, let's erase that one. All right, so we will now divide. All right, hold on. We will now divide. Okay, 245 divided by 150. Okay, see that? 245 divided by 150. So what do we do here first? What we do here is, I'm sorry, we will be actually applying estimated multiplication, of course. Okay. So when we say estimated multiplication, just to give us what do you call this, a hint, an insight of what estimated multiplication is. When you're dividing like this, sometimes you're confused, but you have to actually deal with what do you call this, my friends? Estimated multiplication. So it can actually help you to what? To quickly approximate the result before doing the exact division, right? Okay, so here, what I do whenever I am doing, what do you call this? Uh, what do you call this? Estimated multiplication. Okay, since I have 150, so let me try to multiply 150. I'm referring to 150 multiplied by 2. Okay, so that would be 0. That would be 0. Carry 1. 5 times 2 is 10, right? 5 times 2 is 10, yes. Carry 1, that's 2. Yes, 2 times 1 is 2, plus 1 is 300. Yes. So we have 300. Hold on. Excuse me. So 150 times 2 is 300. Yes. So um, what does this mean? So, okay, how about 150 times 1? Of course, that is 0, 5, that's 150. As you noticed, As you notice, if I multiply 150 by 2, it will already exceed 245. Okay? 300 is already greater than 245. So you cannot have, because basically, when we're dividing 245 to 150, it's like saying, how many 150s are there in a 245? Okay? So if we say 2, then that's wrong because it's already 300. Yeah, when you multiply 150 by 2, it's already 300 and it already exceeded 245. Now, we will say that we only have one 150 in 245. Yes. Yes. Okay, so we have one. Yes, we have 150. It's like answering the question, how many 150s are there in 245? So we have one. We cannot say two because it will exceed 245. Yes, because if I multiply 150 by 2, it's already 300. It's not 245. Yes. All right, so 1 times 150. Okay, 1 times 150, we have 150. Okay, so we subtract 245. 1 times 150, that's 150. So 245 minus 150. So what is 245 minus 150? All right, so of course we bring down 5. Okay, okay, we borrow 1 from 2. So that will be 14 minus 5 would be 9. Okay, yes. 14 minus 5 would be 9. Okay, so we have 95. Yes. Okay, now what do we do? Uh, the next question is, of course, how many 150s? So we're now dividing 95 to 150. And the question would be, how many 150s are there in 95? Of course, that would be impossible. So I have to add a 0 beside 5 of 95. Okay. Now, what do we do now? Okay. Again, we go back to our estimated multiplication. Say if I will, estimated multiplication, yes. If I will multiply 150 by 6, okay, let's do it. That will be 0. That will be 30. Carry 3, 6, 7, 8, 9. That would be 900. Okay, it's almost closer to 950, right? How about if I multiply, yes, 150 times 6 is 900. Okay, how about 150 times 6 is 900. Okay, how about, just to check, 150, let's multiply 150 times excuse me, 150 times 7. Okay, so that will be 0, 35, 7 times 5, yes. Carry 3, 7 times 1 is 7, plus 3 is 10, so that will be 1050. So basically we will say now, okay, that it's actually 6, right? How many 150s are there in how many 150s are there in 900 950? We will say that's 6. So we're going to put a decimal. I almost forgot to put a decimal point right after 1. Okay, after 1. Okay, there's a decimal point. So this will now become 6. Okay, why is it 6? Because as I said, you can see here that if I multiply 150 by 6, we have 150 by 6, we have 900, and it's closer to 950. Now, if I'm going to multiply um, 950 by 7, it's already, no, I'm sorry. I did say something wrong. If I'm going to multiply 150, it's not 950. See? If I'm going to multiply 150 by 7, you can see that 150 times 7, if I multiply that, I will have 1050. So it already exceeded, yes, 1050. So it already existed, it already exceeded 950. Okay? So the correct answer would be 6. Okay? That's what you call estimated multiplication. Okay? So, and then we now multiply 6 by 150. So we'll have 900. There we go. And then we subtract. So what is 950? Yeah. You know, the good important thing in the important thing in math is we really know how to correct what we say. Sometimes the slip of the tongue, we commit mistakes, right? But it's normal. Okay. 950 minus 900 will give us, of course, 50. Okay. Now, again, we're just like continuing division here. So I'm going to add another zero again, because it would be impossible to say how many 150s are there in a 50. It's impossible, right? So you need to add zero. Yes. Yeah, it's impossible to say how many 150s are there in 50 when there is none. So I have to add 0 to 50, okay? So how many 150s are there in 500? Okay, yeah, 150s in 500. All right, so what do we do? What should we do? Okay, so estimated multiplication again. I will try to multiply 150 to 3. Yes, 150 times 3. Okay, so I will have 0, 15, carry 1. So that will be 3 plus 3 plus 1 is 4. So I have 450. Yes, so 150 times 3 is 450. Yes, just to, so it's now closer to 500, right? It's closer. What if we're gonna multiply 150 by, I'm sorry, we don't have a space there. 150, oh sorry. We multiply 150 by, I'm just checking, by best by estimated multiplication. So we multiply 150 by 4. Okay, let's do it. That will be 0, 0, carry 2, so 600. So as you can see again, um 450. Okay, so as you can see, if I'm going to say that the answer is 4 in the question, how many 150s, how many 150s are there in a 500, and if I'm going to say it's 4, it's wrong. Because why? See, it exceeded 600, already exceeded 500, so therefore it would be 3. Okay. Yes. So that's, I hope you're getting it, right? So we're making estimated multiplication here, right? Excuse me. Yes. Okay. So what we do now is, multiply, what do you call this? Multiply 3 to 150. Yes. So 3 times 150 um, will give us, of course, 450. And then what is 500? 500 minus 450, that would be, of course, 50. right? So basically, excuse me. Okay, so basically, it will just give us another answer of 3, right? Yeah, the 1.1.63, right? Yes. Excuse me. I'm having a yes. So, yes. So that's it. So we're just going to have another 3, right? So we stop there. We stop here, of course. Yes. And the sign of our answer, of course, would be negative. Okay. So the final answer would give us, of course, our answer, of course, is 1 point, 1.63, right? I decided to stop by 3 because it will just give you another 3. Okay. All right. So, okay. So what would be the sign of our answer? So since I said a while ago, negative division. Okay. So negative divided by positive, negative divided by positive will give us negative. Okay, so the answer will now be negative 1.63. That's the final answer. It's negative 1.63. Yes, because negative division, negative divided by positive is negative. All right. Okay. See, it's easy, right? Okay. Don't forget to put the minus there. Okay. All right. So that's it. All right. So you see, it's easy. I'm telling you for us to divide um, positive and negative decimals. All right. Okay. So again, the answer is negative 1.63. Next. Okay. So we're done with letter C. We're done with that. We will now go to letter D. I'm sorry about me coughing during the video lesson. Yeah. All right. So what do we do? Again, we do what we I have just said a while ago that we just of course uh, what do you call this? Convert the divisor to a whole number. So always remember that convert the divisor whenever we're dividing decimals. We need to divide a decimal by another decimal, but first we need to convert the divisor to a whole number by moving the decimal point to the right. Okay, and then move the decimal point in the dividend the same number of places to the right, and then perform long division as usual. Okay, so here again, let us deal with the sign first. So negative divided by negative divided by negative is positive. I said it right. I believe so. Negative divided by negative is positive. All right. Okay. Now, let us now perform the long division here. But first, we need to convert by moving the decimal point to the right. Yes. All right. So let us have our divisor first. Disregard the signs. So for our divisor, we have 0.67, 0 point, excuse me, 0.0.67. And of course, we're going to move the decimal point to the right. So if I'm going to move the decimal point to the right, that would be 6.7. Yes. All right. How about for, that's our divisor. Divisor, okay? How about for our dividend, which is, our dividend is 123 or 123.45. Okay, 123.45. 123.4.45, we move the decimal point to the right too. So that will be 1,000. Okay, 1,234. Okay, point 0.5. 1,200 um 234.5. Now you can see that they're not yet both expressed as a whole number. So again, we move again the decimal point to the right. One more time. So move it for our divisor. So this becomes 67. And move it for our dividend. This now becomes one. No, sorry. This now becomes 12,000. Okay, 345. Okay, so both of them now are expressed. So 67 and 12,345. So both of them now are expressed as whole numbers. Now we go now to the long division as usual. All right, let's erase this one. It's gonna be a long one. Okay, now let's divide. Okay, so let's start with where we have more space in our slide. Okay, so let's start with here 12,000. 12,345 divided by 67. Yes, okay. So how do we divide this? Okay, so we actually do this trick of which we start by 3 digits versus 2 digits. Okay, divide the 3 digits to the 2 digits first, so it's not gonna be difficult for us whenever we're dividing, right? Okay, so we say that I'm sorry. We say that what is 123 divided by 67, right? 123 divided by 67. So that's what I meant when I say 3 digits versus 2 digits first, right? Okay, so what do we do? What do we do? Now, of course, we do estimated multiplication here. So if I'm going to multiply 67 by 1, of course, I have 67. Yes, 67 times 1 is 67. How about 67 times 2, right? 67 times 2, okay, 7 times 2, 14, carry 1. So that will be 12 plus 1, 134. Yes. Okay. Okay. I'm sorry. Okay. So 67 times 2. That's correct. It's 134. All right. How about if we will. Yeah. Okay. So as you can see here that when I multiplied 67 by 2, I have 134. And it has already exceeded, yes, 123. So that means to say that I have only 167 in, uh, because the question is how many 67s are there in 123. So I have only one. I cannot have two because otherwise it will exceed. You see, when I multiply 67 by 2, I have 134. So it has already exceeded 123. Okay. So makes sense, right? So 1 times 67, what will happen now? So this will now become 67. Okay, then we subtract. So what is 123 minus 67? All right, so that would be 56, right? Yes, will be 56. So yes, from we borrow one from 2, so that will be 13. What is 13? 13 minus yes, 13 minus 7, that will be 6. And then of course 11, this becomes 11 minus 6. 11 minus 6 is 5. So we have 56. Now, the question is, the question is, how many 67s are there in a 56? Of course, that would be impossible, so I have to bring down 4 here. Okay. So see, we need to bring down 4. So it's not 56 anymore, but it's rather 500 564. Now, okay, so again, we go back to our estimated multiplication. Okay, what if I multiply 67 by 8? Okay, so let's see that one. 7 times 8 is 56. Carry 5. Oh, sorry about that. That will be 5. I'm sorry. My bad. Okay. It's kind of hard to write here. Carry 5, okay? That's a carry. Yeah, it's became big. Okay, so that will be yes. Okay? So I multiplied 7 times 8. All right, 7 times 8, I had 56. Carry 5. Um 6 times 8, 48. Yes, so what is 48 plus 5? What is 48 plus 5? That would be that would be 53. Okay? All right. Okay, so I when I multiplied 67 67 times 8, I now have 500 536. Okay. Just to be sure, just to be on the safe side. What if I'm going to multiply um 67 by 9? Okay? Okay, hold on. My bad, my friends. I'm sorry. All right. I'm sorry about that. Yes. Okay. What if I'm going to multiply 67 by 9? Okay. So let's see. 67 times 9. So 7 times 9 is 63. Carry 1. Okay. So yes. Yeah. 67 times 9. Okay. 7 times 9 is 7 times 9 is, I'm sorry, 63. Okay, carry 6. 9 times 6 is 54, plus 6 is 60. 54, yes, plus 6. 54 plus 6 is 60. Yes, there you go. Now, you can see here 603 or 603 exceeded already 564. So therefore, we will write here the answer, how many 60 in the question, the answer to the question, how many 67s are there in 564 or 564? We have 8. So 8 times 67 will give us 8 times 67 will give us 536, and then we subtract. Okay, we subtract. Okay, what is 564 minus 536? Okay, so we'll now have 20. What we will now have 20. Okay, we'll now have 28. Yes. Okay, why? Because, okay, so if I'm going to borrow 1 from here, that will be 14. That's 8. This will be 5. Yes, 5 minus 3. 5 minus 3 is 2. Okay, and then what do I do now? Excuse me. Oh, excuse me. What do I do now? I do now is to ask the question, how many 67s are there in 28? So it's impossible. Now I have to bring down again 5. See that? Okay. Bring down 5 beside 28. Okay. And now we do the estimated multiplication again to answer the question, how many 67s are there in 285? Okay. So, yes. Okay. So what if I multiply 67 by 4? Okay, let's multiply. So we go back to estimated multiplication. 67 times 4, 7 times 4 is 28, carry 2. So 6 times 4, 6 times 4 is what? That would be 24 plus 2 will give us 268. All right, that would be 268. Now, how about if I'm going to multiply? It's, or 268 is already closer to 285, right? 268 is closer to 285. Now, what if I what do you call this? Multiply 67 just to be on the safe side. If I multiply 67 by 5, okay, multiply 67 by 5, okay, so that would be 35, carry 3, 7 times 5 is 35. Yes, 7 times 5 is 35. Okay, 6 times 7, 6 times 7 is 30, plus 3, that would be 335. Okay, 335. So 67 times 5. Yes. Okay. Hold on. 67, I'm sorry. 67 times 5 will give us 335. Okay. So you see, 335 had already exceeded 285. So therefore, what we're going to write here is, because 268 is closer, how many 268 is closer, yes, to 285. How many 67s are there in 285? Yes, how many 67 are there in 285? We'll now say that it is 4. Okay? Yes, 4. Okay? Got it? Okay. Yes. Okay. So, yes. All right. So, okay, I'm sorry about that. I'm sorry. Okay. So, all right. So, yes, the next step is to multiply 4 by 67. So that is 268. Yes, that is now 268. All right. So we now subtract. Okay, so we have 285 minus 268. All right, so we'll have 285 minus 268. So of course we borrow 1 from 8. This will be 7. And if I borrow 1 from 8, this would be 7. So 7 minus 6 is 1. Yes, and that's already 0 already. So this time, how many 67s are there in 17? Of course, that's impossible. Now this time we will now put a decimal point here, and we will add 0. Okay? We will add 0 to 17. Okay? Or we will add 0 beside 17, to be clear. Yes, because when you add a 0 to 17, okay, when you add 0 to 17, that would still be 17. So the more specific one is put or place 0 beside 17. Yes. All right. So now, so what is 170 divided by 67? 170 170 divided by 67. So are there um how many what do you call this? Oh, my bad. How many 67s are there in 170? So we go back here in our estimated multiplication here, and we go back to 67 times 2. So we have 134 already, okay? Almost closer to 170. How about 67 times 3? Okay, I haven't shown that yet. 67 times 3. 67 times 3, that would be 1, because 7 times 3 is 21. Carry 2. 6 times 3, yeah, 7 times 3 is 21. That's why we have 1 and then carry 2. Okay, and 6 times 3 is 18. 18 plus 2, what is 18 plus 2? That will be 20. Okay, so we have 201. So it has already exceeded 170. So therefore, um, we would say how many 67s are there in 170? We would say that it is actually two. Okay, two. All right, there you go. I hope we still have a space. So we have there two. 2 times 67 will give us 134. We'll just maybe have two decimal places here. Okay, 134. Yes. How did we get that? 2 times 67. Then we subtract. All right, what is 170 minus 170 minus 134? Okay, so we borrow 1 here. This will become 6. Yes, 6. And this 10, that will be 6. I'm sorry. And this would be, what will happen here? 6 minus 3 is 6 minus 3 is 3. 6, yeah. 6 minus 3 is 3. Okay? So we're going to add another, we're going to put another 0 beside 36. Okay? Because, of course, it would be impossible to answer the question how many 67s are there in 36. So that's why we put 0 there. All right. So, okay. Put 0 beside 36. Okay? All right. Yes. So that's it. Um, yes, 170 minus 134 would actually give us 36. And then we added, we placed another 0. Okay, let's continue our division. That's why this is the long division already. All right. So, okay, now how many 67s are there in 360? Okay, so how many? How many? Okay, we look at the estimated multiplication we had just done a while ago. So again, how many 67s are there in 360? Okay, let's see here a while ago. Okay, so when I multiplied 67 by 5, 67 times 5, I had 335. When I multiplied 67 by 6. No, I don't have that yet. Yes. So let's see for us to be on the safe side. 67 times 6. All right. So, yes, 67 times 6. Because I have already 67 times 5. That is 335. Okay. How about 60? Yeah, 335. Yes. That's 67. 67 times 5 is 335. Yes. I might say it wrong, so I just repeat it again. 335. All right. So 67 times 6. So what is 67? 67 times 6, okay? All right. So we have 42. 7 times 6 is 42. Carry 4. 6 times 6 is 36 plus 4. 6 times 6 is 36, plus 4 would give us, okay, would give us, of course, 40. All right, so that's 402. So as you can see, between 67 times 5, which gave us 67 times 5, which gave us an answer of 335, and 67 times 6, which has an answer of 402. Okay, 402 had already exceeded 360, right? It had already exceeded 360. So therefore, the answer would be 5. Okay, 5. Yes, 5. Okay. And then 5 times 67 would give us 5 times 67 would give us 335 over here. Okay, and then we try to subtract that again. 360 minus, what I meant is 360 minus 335. Okay, what is 360 minus 335? Okay, so it will give us 25, right? Okay. Yes, it will give us 25. Yes. All right. Yes. So why? Because, okay, we borrow 1 here. That will be 5. Yes. 10 minus 5 is 5. And then 5 minus 3 is 2. Okay. So that would be actually 25. Now, here we don't have enough space already, right? We'll just add another 0. Basically, if we keep on going, we'll have the next digit would be 3, and the next digit would be 7. Yes. Okay. So, yes. So, but we can actually round our answer to two decimal places. Okay. Why did I say that? Rounding to the to two decimal place, or that's actually two decimal places means hundreds place. So to round this, I'm referring to the quotient already. Okay, the answer, not product but quotient, because we're talking about division. We have 184. Okay, point 184.25. Okay, 3 7. Okay, so we round it to two decimal places. So let's actually look at the third digit after the decimal. So it's actually 3. Okay, now since 3 is less than 5, 3 is less than 5, we can just say that our final answer would be 184.25, right? Okay, that was a long one. Okay, that the answer now, the final answer is 184, 184.25. And why is the answer positive? Because, in the rule of division, let's go back. In the rule of division, okay, it says here, negative divided by negative is negative divided by, because we're dividing, negative divided by negative is positive. All right. See that? It was a long one. So our final answer is 184.25. 184.25. All right. So I hope it makes it clear to you on how to actually and divide, multiply and divide positive and negative, positive and negative decimals. All right. Okay. All right. So this time it's your turn. So you now multiply 3.6 times 5.2. Okay. You multiply that. And then you have also negative 4.8. Okay. Negative 4.8 times 3.1, and then multiply negative 6 negative 6.75 times negative 2.3. Okay, so you know the rule: negative times negative is positive. Yes. I'm already giving you a hint or a clue for the sign of the answer. So negative times negative is positive, and then for B, negative times positive, negative times positive is negative. Yes, negative times positive is negative. Okay, and then yes, so it's your turn, of course, to do all of this. Yeah. All right. So I hope you can actually to do this. If you have a piece of paper or ball pen at home while watching my video, you can just do it on your own, by also watching the explanation. If there are things unclear to you, you can just pause and go back to the discussion and examples which I have provided during this video lesson. All right, then another thing is another problem that you will answer in your own in the comfort of your homes is the math problem here about the road about uh, uh, the rotary walkway in Buffalo Wallow Park in Odessa, Texas. So the problem is all about uh, the walkway, the rotary walkway, which spans a length of negative 185.6, negative 185.6 meters, okay, measured in the opposite direction due to construction changes. The walkway is being divided into sections, and each section will be negative 8.4, negative 8.4 meters long. So the question is, how many sections of the walkway will be there? All right, so that ends my video for today's episode. I hope we learned a lot, and please do like and share and subscribe in all my video lessons in this channel. And with that being said, I wish you a good day and God bless.